And meshes are primarily what you're going to be working with when you're doing the authoring in the SC library. So what is a mesh? Well, a mesh is basically described by a point list. So we have points, normals, and texture coordinates, and face, polyline, and point elements indexing into the point list. So what this means is we're going to build up this giant list of points, and then we're going to have these different lists that index into this point list to describe our faces, our lines, and then our just points. So these are the types of geometry that we support, and you'll notice that this kind of matches up with some of the draw modes that we saw yesterday. We can display just the faces, just the polylines. We don't have a specific draw mode just for points, but we do have a point cloud mode that utilizes this. So these elements are the primary building blocks of what you're going to see on the screen. And the concept of a point list is pretty familiar, I think, to a lot of people who deal with describing, models in a graphics system. So now, in order to control the display properties, we do have materials that are applied to meshes, and you can create these material maps, which will let you kind of predefine these materials and index into a material array. But we'll talk about that a little bit later. And then one thing we do want to talk about on meshes is meshes also have some flags that control different rendering. So for example, you can set on a per mesh level, you can set things such as back faces being visible, or you can set the handedness of a certain mesh. So we have a number of different flags that control it on a granular level for meshes. So what does working with meshes look like? So here's some example code. So a mesh is like a struct, and we can set different properties on this mesh. So by default, you create a new mesh, and it's just empty. So you can set, there's a number of arrays that are attached to a mesh that control the list that we talked about on the previous slide. So we have an array to set all the vertices, and we can create arrays for the face list and the edge list and the point list. And we describe those, as you can see here on the slide. So we can also have to insert meshes into a model. Okay, so we talked about a model being sort of the topmost container. And a model contains, remember, all of the data that we author in the stream cache. So whenever we create an object in the stream cache, such as a mesh right now, we need to insert that into the model. Okay, and what we get back from doing that is we get back a unique key for this particular mesh. And we're going to want to hold on to this key because we're going to need it later when we do instancing, which we'll talk about here. But the idea to take away from this is that the mesh holds the geometry. Okay, and it holds the actual geometry and these flags that describe how this geometry is going to be rendered. So we're not, at this point, we're not concerned with things like textures and that stuff. That's going to come later. Strictly the mesh is just the points. So you can imagine if you're coming from a different graphics system, maybe your file format has, gives you access to all this data. You're going to want to take that geometry data out of your source system, and you're going to want to massage it and put it into this mesh class. And in general, you can think of one mesh consisting of one object, one logical object to draw. So this is a picture that sort of illustrates how it all kind of comes together. So here on the left, you see we have these different types. We have the points, we have the normals, we have the UV, combined with the flags, and that's attached to the mesh. Okay. Now, one other thing that we have the ability to do in a mesh is define these face elements, the polyline elements, and the point elements. So, what is the difference between these? These are a logical grouping of the points, normals, and UVs, which create this idea of a face. So a face is different than a triangle. A triangle is we use for drawing, but a face we can we can specify a number of these points that create the CAD face. And a CAD face is like, you can imagine the top of a table could be a CAD face, or the side of a box, or something like that. Likewise with polyline elements, we can define edges, so the edge around the table could be defined. And we simply create groups of these elements that instruct the system that these CAD concepts exist in this mesh. And the reason we do this is for down the road when we do measurements and things of that nature, we can say, okay, what face did we pick? Or what line did we pick? Remember when we talked about, in the picking lecture, we talked about, when we do it from a specific point on the screen, we can get that additional detail. And this is what's driving that. By defining these face elements, the polyline elements, and the point elements, we're kind of building in this additional knowledge into our mesh. So, I mean, yeah, we could just say, for the face elements, we can just put all of the face, all the points could just be in one face. But that wouldn't really give us that granularity for selection and measurement. So we do have to do a little bit of work to define these specific CAD concepts of a face, a line, and a point when we build our mesh. But it does help us later down the road. So if you're not interested in any of that, or it's possible that maybe your source file doesn't support that, then you would just kind of place all of them into one face element. Like, for example, maybe a source format like OBJ doesn't really have the concept of a CAD face, right? So in that case, maybe you only have one face element because that data just doesn't exist. But for systems that do, these elements allow us to build that additional logic into our mesh. Okay, so now that we have meshes, what do we do with them? We need to display them on the screen. And the way we do that is we instance a mesh. So even if we only have one model, one mesh, we still need to create an instance of that mesh in our scene. And well, the concept of instancing is fairly well understood, but I'm just going to talk about kind of how we do it in the SC authoring, and then we're going to do some exercises of that a little bit later to get some practice. So, like I said, creating the geometry, creating a mesh object, and inserting it into the model does not mean it's going to show up on the screen. We need to create an instance of it to actually have it displayed. So what does an instance entail? Well, the big one is that it's a mesh, obviously. But we also have some things that are attached to that mesh. So we attach a matrix to it, a material, visibility, and additional modifiers. Okay, we're going to talk about kind of each one of these in turn. So the matrix, fairly straightforward. The matrix is going to tell the system where this mesh is in the world. Okay. The material, again, an understood concept. We're going to talk about the rendering properties, the color, face color, line color, point color. All those we can control individually on the material. If it has a texture, the texture is going to also be in that material. And the visibility, you can either set like a default on or off. And then modifiers. So additional modifiers include kind of non-rendering related things. So for example, maybe we want this to not be selectable, or maybe this mesh renders in a certain way. There's a number of modifiers we can look at in the documentation that we can control on a per instance basis. Okay, and what we get back is we get back a unique instance key that can be used for mapping. And what we mean by that is if you think back to we talked about mapping our external business data to our stream cache data. This is one way we can do that. When you're using the authoring library, this key is given back to you, and then this is your raw stream cache identifier. Using the hoops converter, we make use of this key for our own mapping for our assembler tree. And the function that we use to specify or to create an instance is this sc store model instance function. And this function has a number of different overrides, so we can specify some default values if we need to. But this is kind of the main entry point to creating instances. Okay, so now that we talked about that, I want to talk a little bit about those concepts that we discussed with the elements. So we have the face elements, and kind of what that means and what it looks like. So we see here each face element is defined by a unique ID in the face element vector. So what this means is that when you create a particular face element, the ID is sort of where it exists in that array of face elements. So what I mean by that is, let's say I have a table and I want to, or a cube, and each side of the cube I want to be a face element. So I would specify for the top, the 4 vertices that make up the top of the table. Now that would become face element 1, all right? Because I insert those 4 points into that face element list first. It actually might be 0. So then, say I wanted to know the bottom. Okay, so I would insert the 4 vertices into that face element list for the bottom, and that would become face element 1 or 2, however we're counting. And then when we select that, we can that will be the ID that we get back from that selection object kind of in Communicator. So we know we get back number 0, like that we click on the top one. So that is the idea of the unique ID of the face elements. And then we can use a material map to map a specific material to a face of a mesh. So if we want to apply a certain material just at the top, we can set that for index 0 or ID 0, and we can likewise set each one individually. So instead of just applying the material to the whole mesh, we can also apply them to faces. And the same is true for polyline elements. So if we want certain line elements to be different colors, we can override those explicitly. Okay, so we talked about when we made an instance, we talked about setting matrices and setting materials, and we refer to these as attributes. These are attributes of an instance. And these are inserted into a model just like geometry, and they each have a unique key. So before we can make an instance, we have to create a matrix, we get back a key. We create this material, we get back a key. We create a material map, we get back a key. And then each one of these keys can be reused, right? So if we have a number of different material or objects that use the same material, for example, maybe we create a material that has green faces and blue lines. If we want multiple of our instances to use the same material, we can specify that same key. And then when we actually create the instance, what we're passing into that instance function is simply keys of a matrix, key of a material. So it allows for greater reuse within the system. Okay, and this diagram will just kind of drive it home how how everything comes together. So we have our model, which is that topmost container. The model contains instances. Instances consist of a mesh and a matrix and a material and some other things. But you can kind of see instances at the heart of everything here in the SCL offering.